All right, guys, this is Intro to Redox. It is Memorial Day. I am filming this. I know the angle is less than ideal, but you'll survive because it's just the way that it is, and I'm out on my porch, see my lovely fern. So we're talking about redox, and redox is a little bit tricky, but it's kind of cool and it's really interesting, which is why I really wanted to expose you to it and show it to you. My neighbors are also building something in their backyard, so you might hear some saws. It's great. Everything's fine. So redox stands for reduction and oxidation. Okay, and reduction and oxidation are two parts that have to happen together. They can't happen separately, okay? And so that's where for those of you that don't recognize, redox comes in, okay? So we say a redox reaction, we mean oxidation and reduction, or reduction and oxidation. They have to happen together because what they ultimately lead to, okay, is the transfer of electrons from one substance to another. So reduction, okay, reduction means gaining electrons. So the substance or the species that's reduced is actually gaining electrons, and its oxidation number is going to get smaller, because if you're gaining negative electrons, your oxidation number is going to go from 0 to -2 or 0 to -3, something like that. And therefore oxidation probably makes sense that it's the opposite, which is losing electrons. Okay, and its oxidation number is going to go up because remember, electrons are negative. So if it's oxidized, you've probably heard that term before. You've heard like, oh, this nail is all oxidized, right? So if you're thinking about that, oh, I don't want to move me. There we go. So if you're thinking about that, I might think about an iron nail, and I might say, okay, this nail is oxidized. There you go, Will. There's my favorite Z that you love, okay? So when I picture an oxidized nail, okay, I picture it all orange, right? Rusted. Rusted and oxidation kind of go together in this sense. And that's really what I want you to kind of get from this. So when you have an iron nail, when you have a nail, it doesn't look like a nail, but it's what we're going to go with, okay, guys? So this is a nail. It is made up of pure iron. And that pure iron has an oxidation state of 0. Now, we've talked about oxidation states before. I'll make that 0. There you go. We've talked about oxidation states before because oxidation states are essentially the charge on that atom. When it's just a chunk of iron, the oxidation state's 0. Okay, all of those iron atoms, let's think about this being made up of all these iron atoms. They are held together by metallic bonds. And those of you who are super good out there are going to think about metallic bonds as a sea of mobile electrons, okay? So none of those iron atoms have gained or lost any electrons. So they're just straight iron, okay? They have 3 valence electrons or 2 valence electrons. I don't remember. It's been a while since I've looked at a reference table, guys. Then when it's oxidized, what happens is it reacts with the oxygen in the air. So there's oxygen in the air. So oxygen in the air, see how it's O2? Also has an oxidation state of 0, okay? So there's a little bit of wind, so that's going to sound great for you guys. It's fine. So when oxygen is in the air, any element that's alone, that means not bonded to another element, has an oxidation state of 0. So the oxygen in the air is going to react with the iron, okay? And when the oxygen in the air that has an oxidation state of 0 reacts with the iron that has an oxidation state of 0, what happens is that electrons are transferred, okay? And electrons are actually transferred from the iron to the oxygen, okay? So it's from the iron to the oxygen. Now let's go back up to what we talked about up here, right? Let's see if I can do this. So the iron is losing electrons, right? It's losing electrons, and the electrons are going from the iron to the oxygen. Since the iron is losing electrons, we would say that the iron is being oxidized, because oxidized is losing electrons. The oxygen, however, those electrons have to go somewhere. You can't have any little orphan Annie electrons, okay? They always have to belong to somebody. So the oxygen is gaining electrons, and therefore it is reduced, okay? And so here's kind of the equation that's happening. Let me switch to this. I know you can't, that's really hard to see. It's fine, don't worry about it. Okay, so here's what's actually going on. Let's do it in blue. Why the heck not, okay? So I've got iron, which has an oxidation state of 0, plus some oxygen, which also has an oxidation state of 0, turning into iron oxide, and that is rust, okay? So that's what this is. This is rust. So that like orange stuff that you see is really like iron 3 oxide. So if I look at this compound right here, you can see here, we know if you look at your periodic table that oxygen has an oxidation state of -2. So oxygen here has gained electrons, okay? And iron has an oxidation state of +3 in this case, okay? And I can kind of see that, and I'm not going to worry about you figuring that out. Some of you might like actually be able to, and you see that oxygen has an overall negative charge of -6, and therefore iron has to have an overall positive charge of +6, and that's where those numbers come from. But if that doesn't make sense, it's okay, okay? So iron went from 0 to +3. So what happened is it lost electrons. Oxygen went from 0 to -2. Okay, so what happened to oxygen is it gained electrons. Here's what you need to know. You need to know that all of the electrons lost by iron are gained by the oxygen. That's why you can't have, I don't even want to make that O2, I want to make that O. That's why you can't have oxidation without reduction or reduction without oxidation. They have to happen together. So this is really cool, and there's a lot of really cool like applications to it, but the biggest thing here is recognizing that when you have oxidation, you have to have reduction. When you have reduction, you have to have oxidation. And you can always tell that something's a redox reaction because you're going to have something that's alone on one side, okay? And this is almost always true, but for our purposes of like remote learning chemistry, it's going to work for us, okay? When you have something that's alone in an oxidation state of 0, it's going to be a redox reaction because it's not going to be alone on the other side. So it's going to have gained or lost some electrons. So look for something that's got, and look for a reaction that has something that's alone. So your most common redox reactions are going to be synthesis reactions, like N2 plus H2 forms NH3. Okay, so here my nitrogen is 0 and my hydrogen is 0, and here they're not 0, okay? One's going to go up and one's going to go down because there's going to be a transfer of electrons. Additionally, combustion reactions, like CH4 plus 2O2 turns into CO2 plus 2H2. Oh, in this case, here's your oxygen, and it's got an oxidation state of 0, and over here it's -2. So actually, it's the carbon here that that loses the electrons. It goes from -4 to +4, and your oxygen's the one that gains the electrons. Oxygen's really good at gaining electrons. That's why we call it being oxidized. That's why we call the other thing being oxidized. Sorry, because oxygen's very easily reduced. So when it reacts with oxygen, it's very easily something's very easily oxidized. I hear something banging inside my house and my kids are napping, so I'm a little nervous that my son is like doing something that he shouldn't be doing, but it's fine. It's fine, guys. Don't worry. So that's the introduction to redox. I'm going to let you do a simulation on an electrolytic cell, or in a voltaic cell, excuse me, and I'm going to show you kind of what that is and what's going on there, because I think it's really neat. And that's probably going to be all we do for redox because there's not too much to it. I just want you to kind of recognize what redox reactions are. Another kind, forgive me, is single replacement. I know this is all over the place, guys, sorry. Single replacement reactions are also redox reactions because you've got somebody that's alone. I don't know why I picked tin. That's a terrible idea, but that's okay. So here tin is 0, and here it's +2, and Ag is +1, and here's Ag is 0. So tin is oxidized because its oxidation state goes up, meaning it lost electrons. adhere. Silver is reduced because its oxidation state goes down. It goes from +1 to 0. I would balance this with a little bit of that and we'd be all set. All right, so that's a little intro to redox, and I'll come back and show you a little bit about voltaic cells and what cool things some cool applications we can do with this.